come again with this new class to teach you more on calculation based on level, how to calculate level transmitter, some calculation that you can simulate to your control so that you have your necessary value to do your simulation, to do your also know what to input in your mechanical completion sheet. It's a mechanical completion sheet for a compressor. But this sheet is not the same thing for level. I'm just using it as an illustration for my people to know what to do. Like as you can see, this is a data is a functionality instrument functionality check from B for the level transmitter, because we are dealing on level. As you can see, the level transmitter value is the tag number is 5LT 75031. We did this particular calculation in an FPSO. That's where I did this calculation. So I want to let my people know, especially those of our students, those that are new to the instrument field, you need to know this. As you can see, this is our various values. The range of the transmitter from here is -21 to 305 millibar. And you know our level is always on millimeter. We are measuring the level of a tank, it's always on millimeter. That's why you can see here the level is 290 at 91%. Is 290. This is the trench O. We also do the calculation of the trench O, the calculation of the watts and the low value. So what I want you to know is this value you are seeing here as a low. This value here. This value you are seeing here. Yes, represents 91%. At 91%, it's supposed to have 2,900 millimeter on the length of the tank. This one is the alarm value. This threshold value you are seeing here. This threshold value is alarm value, alarm I. We have alarm I. There's no need for alarm I. They didn't give the value. We also have alarm low. At alarm low, they give us the value of 8. This 8 represents 8% and 250 millimeter. Because you need to use this value to calculate it for you to get your what to simulate on your Druk. It's unfortunate that I'm in my hotel room and I'm not with Druk. I just want people to do the calculation. It's very, very important. So I've come again. As you can see from here, this is our range. It's our chemical storage tank in FPSO, and the calibration check on the transmitter is 5-LT-7503. It's a level calculation we want to do on level transmitter on tank. The range you can see here is range from -21 to 305 millimeter bar. We have threshold value which is 91. Our threshold value here is 91. As you can see, our threshold value is 91. So from here, you see our calculation. We see this is the formula we use. Percentage of value is equal to 100 times span plus low range value for calculated value. So for you to go, you need to calculate your span. This is our span formula, upper range and lower range. And our upper range value here is 305 millimeter. Our low range value is -21 millibar. So from here we have our span. Our span is 305 minus here you have a 326 millibar. So from here we did our calculation. At 0%, you do your 0/100 times the span plus low range value. You have what? -21 bar. 25%, 25/100 times span minus 20 low range value. You have millibar. At 50%, this is what we do. 50 over 100 times here minus 21, you have your millibar. At 75, we did the same thing. At 100%, we did the same. 100 over here, we have 305. And our threshold value, which is 91. So we come to this side. 91 over 100 times 326. 91, we have our threshold value to be what? 297 millibar. And our threshold load, that is low alarm, is 8 over 100 times 2326, and we have 5 millibar. I hope my people understand. Just go through this calculation very well. Go through this calculation very well. You can see everything is detailed out for you to understand. So this is tubular value. I now tubulate it. Our input value 25%. This one is from DCS. If you simulate in the field, it will joke at minus 21 bar. What the DCS will be showing? This is your milliampere equivalent. At 25%, you have 60.5 millibar, 61 millibar. DCS will tell you its own value. This is your millimeter equivalent. 50%, you have 1427 millibar. DCS will tell you its value. This is DCS output now. Why? From your milliamps, you have 12 milliamps. 75, you have 223 milliamp, 0.5 millibar. DCS will tell you this is 16 milliamp equivalent standard value. 100%, 305 millibar. DCS will tell you what is seen. DCS may be seen in millimeter because it's washing the tank level. The millimeter equivalent, which from this calculation, from this place, you saw a millimeter. So from here, I can also do a calculation to get the length of the tank. So from there, you can see at 91%, which is alarm, we have 297 millibar and 90 milliamps. This is for your DCFs. And also at 8% load, 55 millibar. This is so valuable. What I have at my milli. But I want to also tell you this 19 and 20, 19 and 5 millibar. I also did some calculation. This is the formula applied. S% minus 0, 100%. After I'm black, this S milliamp. I'm looking for S milliamp now, which is this 19 and this 5. So from here, in this formula, 91% S, which is 91% of I trench or I alarm. 91 after the calculation manipulation. What I have is what? 90 milliamps. That of 8% we have what? Out of 8% we have 5 milliamps. So that is what I have, my people. As you can see from this our mechanical completion sheet. If you're not completing mechanical completion sheet, you come to this side and input this value at 21%, at 0%, 25%, 50%, 75%, 100%. You input them. Without those value, that's why you need to know this calculation very well. This calculation is very important. Without that, you can complete your mechanical completion sheet. Yeah, this is. Thank you, my people. I know you have learned this thing. Because of the time, and you know it's data. I want you to do your own calculation. Just follow up with this calculation. Follow up. You will know how to do it. You know this is from your transmitter and this from your data sheet. This is called data sheet. So it's called your data. See your mechanical completion functionality check. Also part of mechanical completion sheet. It's called functionality check too. So you can see.